Hey everybody, this week we're going to talk about chatbots and their operations in the world of NLP. So this first section will discuss the introduction to chatbots and what are some of the fundamentals to NLP and what are they designed for. In this section, we will not only cover what chatbots are, but also the key components of what makes a chatbot, particularly focusing on NLUs and NLGs. You'll gain a fundamental understanding of chatbots, processes, inputs, and how to generate responses. They are the driving forces behind AI-driven chatbots, and understanding them will give you a deeper insights to how the language of this technology works. To start, chatbots are software applications designed to stimulate human conversations. They rely heavily on NLP's techniques to interpret user inputs and respond accordingly. There are two main types of chatbots. A rule-based chatbot, which we'll do for our first project, which follows a predefined script and pattern. And then there's an AI-driven chatbot, which uses machine learning and NLP to interpret and respond more dynamically. This is something we'll do later on. These chatbots can be used across many industries, from customer service to virtual personal assistants like Google or Alexa, where they can enhance user experience by automating repetitive or simple tasks. So understanding NLUs. So now let's dive into natural language understanding, or NLU. This is where the chatbot takes the user's input, whether a question or a command, and breaks it into something the systems can understand. NLUs is responsible for intent recognition, which helps the bot which actually helps the bot figure out what the user wants, and the entity extraction, where specific pieces of information like the dates or locations are pulled from the input. For example, if a user asks, "What's the weather in Chicago?" the bot uses NLU to understand the user's intent to ask the weather information, and it identifies Chicago as the relevant entity. Without NLU, the chatbot would be unable to grasp the meaning of what's being said here. After NLU processes the user's input, NLG comes into play. This is the process by which the chatbot generates a response that feels natural and human-like. NLG starts by determining what is the content needed to be included in the response, followed by the sentence planning, where it is structured the response logically, and finally surface recognition, where the bot generates a grammatically correct sentence. For instance, after understanding the query, "What is the weather in Chicago?" NLG would produce a response like, "It's sunny and 75 Fahrenheit in Chicago today." The goal of NLG is to make the chatbot responses sound more natural and engaging. Next, we'll jump into the NLU pipeline. This is a series of steps that the chatbot follows to break down the understanding of the user's input. The first step is called tokenization. We talked about this a couple weeks ago, where the input is divided into individual words or tokens. Then the POS, or part of speech, tagging identifies the grammatical role of each word. The system then moves into intent recognition to determine what the user wants, and the entity extraction to pull out specific data like names, location, or times. This process allows chatbots to make sense of user queries in a structured way, enabling it to provide relevant responses. So to continue on it, once the bot understands the input, NLG steps in to generate the response. It begins with the content determination, deciding what is actually needed and what is being said. Next, the chatbot structures the response through sentence planning, making sure it's logical and coherent. Finally, it then moves into surface realization, generates the response in a grammatical, correct, and natural sounding sentence. This process is crucial because it ensures that the chatbot's responses are clear and user-friendly. So let's go back to our example. For instance, if the user asked, "What is the weather in Chicago?" The chatbot can respond with, "It's sunny and 75 Fahrenheit in Chicago today." This makes the interaction feel much more natural. So what are some challenges between both the NLU and the NLG? So both of the NLU and NLG have challenges that chatbots developers must navigate through. So for instance, for the NLU, one of the big challenges is ambiguity. When the user input is unclear or vague, the system may struggle to interpret it correctly. For NLGs, there is the issue of response variabilities. So without a proper train or data, the chatbot can fall into a trap of generating repetitive or overly generic responses, which can feel robotic or unnatural. Additionally, both of these processes are data dependent. High quality NLUs and NLGs require large and diverse data sets to perform effectively. Without the data, the chatbot's ability to understand and generate human-like language becomes very limited. So in this section, we'll talk about the different types of chatbots. So the learning objectives for this section is we will not only explore the different type of chatbots, but we'll also dive into challenges and design considerations that comes with building these systems. As we discussed, chatbots have the potential to revolutionize industries such as customer service and user interactions, but they're also faced with significant obstacles when it comes to handling complex conversations, understanding context, and maintaining an engaging experience for users. By the end of this section, you'll be able to identify key challenges in chatbot development and think critically about how to design a chatbot that is effective, user-friendly, and scalable. So as we talked about before, one of the chatbot styles is a rule-based chatbot. So these bots rely on predetermined rules or decision trees to determine responses. While rule-based chatbots are simple to set up, they face significant challenges, especially when it comes to handling ambiguous inputs. If a user asks a question in a way the chatbot doesn't recognize, the interaction can break down quickly. Design considerations for these chatbots focus on anticipating the most common user questions and ensuring that there are feedback responses when no matches is found. For instance, a rule-based chatbot might say, "I'm not sure, I don't understand, could you clarify?" when it can't match an input to a specific rule. These bots work best in scenarios where the conversation is predicted and limited, such as handling frequently asked questions or simple customer service tasks. Next is the AI-driven chatbots that takes things to the next level by introducing machine learning and NLP to understand user intent and generate more dynamic responses. However, these bots face their own set of challenges. First, they need large, diverse data sets to be trained effectively. Second, they are computationally expensive, requiring more resources to maintain compared to the rule-based bots. When it comes to designing an AI-driven chatbot, it is important to think about how to handle user expectations. Users often expect these bots to understand everything they say, but in reality, even the most advanced AI bots have limitations, particularly when it comes to complex language structures or specific domain knowledges. Ensuring that your chatbot can handle edge cases and managing user expectations around personalization are key to creating a satisfying experience. Next, what we have is kind of a hybrid chatbot. And hybrid chatbots are a combination of a rule-based and AI-driven bot, designed to leverage the strengths of both approaches. For example, a hybrid chatbot might use a rule-based response for simple queries, but switch to AI-based responses for more complex interactions like understanding a user's intent or engaging in longer conversations. One of the main challenges with a hybrid chatbot is balancing simplicity with complexity. You want the chatbot to be able to handle basic tasks effectively while also being capable of more complex interactions. This requires a powerful design to ensure that the chatbots can transition smoothly between rule-based and AI-driven sections of the conversation. For instance, a hybrid bot can handle routine inquiries about business hours, but switch to an AI-driven approach when a customer asks about a specific product recommendation. So some of the common challenges that we have within the AI are with the chatbot designs are, regardless of the different types of bots, there are several common challenges in both of the chatbot designs that developers must address when doing it. And as mentioned before, ambiguity is a big one. Users don't always ask questions in a clear or direct manner, which makes it difficult for chatbots to interpret the input. This can lead to frustration if the bot continuously misunderstands the user's intent. One solution is to design a bot in which more fallback mechanisms and offers users suggestions for how to rephrase their queries. Content retention. Many of the chatbots struggle with remembering details from previously or earlier conversations. Imagine a scenario which a user asks a question and the chatbot answers, but the bot then forgets the context in which when the user follows up with another question. Building a memory capability into your chatbot is a key for improving the flow of conversations. Engagement. Chatbots needs to be engaging enough to keep the user interested, but too much formality or repetition can quickly lead to negative experience. To avoid this, try diversifying your responses and infusing personalization into your chatbot, giving a more human-like response and tone or humor to help sustain engagements. And then finally, let's discuss some of the key considerations for designing and building an effective chatbot. User-centric designs. Always prioritize the user experience here. Consider what your users need most and design your chatbot around those specific use cases. For example, if users often ask for support, make it easy to navigate to that function. Scalability. As your chatbot becomes more popular, you need to ensure that you can handle the growing traffic without sacrificing performance. This often involves optimizing the backend systems, reducing lag time, and improving the chatbot's response time. And then accessibility. Make sure that your chatbot is accessible to all users, including those with disabilities. This might involve supporting voice commands or ensuring that the bot is compatible with screen readers for visually impaired users. Prioritizing accessibility is not only the right thing to do, but it can expand your chatbot's user base. And then let's talk about a case study here real quick. To bring everything together, let's look at a real-world example of a case study where a hybrid chatbot was implemented to improve customer service. In this example, the chatbot was used to handle routine questions with rule-based responses while switching to AI-driven dialect for more complex customer inquiries. The chatbot is designed, the challenge is designing this bot includes balancing the simplicity of rule-based with the flexibility of AI, ensuring that the bot could handle both efficiently. The result was a significant reduction in response time, as well as an increase in customer satisfaction due to the chatbot's ability to handle more complex conversations. This is an example of how it is important to carefully plan your chatbot structure and ensure that it can meet the user's expectations without overwhelming the system. And in this final section, we'll actually talk about how to create a SimpleBot class within Python. So in this section, we'll dive into the basics of Chatbot using Python. We'll work on this SimpleBot class, which uses the pattern responses to interact with the users. We'll also implement generic feedback responses to handle user inputs that don't match any predetermined patterns. By the end of this section, you'll be able to have the skill to build your own chatbot and understand how the simple pattern matching can drive basic conversational within AI. So let's break it down. Let's break down the structure of the simple class. The constructor is where we define the chatbot's pattern. These are regex expressions that match specific inputs. For example, if the user types in a hello or hi, the bot responds with hello or hello there. We also define generic responses for cases when the bot doesn't understand the input. This prevents the bot from breaking the flow of conversation when it encounters something unfamiliar. The response method the response method processes the user's input, searches for pattern match, and responds and then returns a response. If there is no match, it will then return one of the generic fallback responses. Now let's take a look at what the code could look like. So for this walkthrough, we'll talk about the SimpleBot class. So here we have the different codes, and the chatbot uses a regular expression to match users' input against predefined patterns. And again, for an example, if the user says hello or hi, the chatbot should respond with hello or hi, how are you doing? The generic response, the generic underscore responses list holds fallback responses that the bot uses when no pattern matches. This ensures that the bot does not break when it experiences unexpected inputs. The response method then goes through each pattern, checking if the user input matches any of the predetermined responses. If it finds a match, then it returns a random response from the corresponding list of responses. If no matches are found, it picks a fallback response from the generic list. Next, so for this, I want to show you the different lines of code. So here's some examples that you'll be able to use. So when we look at this, we understand that we initialize that the bot. So sorry, let me backtrack a little bit. So when we take a look at this SimpleBot, we'll see how it works in action. So in this example above, we initialize the bot and test it with various inputs like hello, how are you, or bye. The bot responds appropriately based on the pattern recognition pairs we defined. When we input hello, the bot should respond with hello or hi there, randomly picking from the list. Similarly, when we ask how are you, the bot should respond, I'm fine, I'm doing well, or how are you? If the input doesn't match any of these patterns, again, it is going to fall to the fallback generic responses. So now as we understand how the SimpleBot works, it is time to get creative and add your own custom pattern response pairs. You can personalize your bot by thinking about what kind of conversation it will handle. For instance, if you're working on a bot for customer service, you might want to include patterns like what is your business hours or how do I reset my passwords. Experimenting with the regex to capture different variations of user inputs. So for example, you can expand the greeting pattern to match hello, how are you, hey, or yo. If thinking about creating a more thermic bot based on particular use cases. For example, you can build a bot with a fun, playful, personalized, or formal tone that can then reach different parts of audience. So when you're designing this, make sure that when you go through it, you get to play with it and personalize it and see how you want to build your bot. So to summarize everything that we've talked about today, and I know it's been a lot, we talked about how we can build a simple chatbot using Python, exploring how the different responses pairs enables the bot to match different user inputs with the relevant responses. And it is important, again, to make sure that you have fallback responses if the user input does not match any of the predetermined responses. So moving forward, we'll build out more on what we learned today and continue to work towards adding all of the elements to your group project. to encourage you to experiment with the code, add new patterns, personalize your bot, and create meaningful responses tailored to a specific theme or use case. This is a great step to building out our chatbot that is simple, predetermined, and then later on, this information that we're learning now will then move more towards developing our more advanced systems. Thank you, and if you have any questions, again, feel free to reach out. Take care.